I'm going to talk about the evolution of the periodic table. First of all, in the early 19th century, scientists didn't know atom elements, but they didn't know how to organize them. Then Dalton proposed the atomic theory, suggesting each element is made of atoms with a specific weight. Then John noticed that some elements could be grouped in these traits bases on similar progress in atomic weights. Then John arranged the elements in order to increase in atomic weight and noticed every 8 element has similar properties. Then Dmitri created the first widely organized periodic table, arranged elements by increasing the atomic weight, then left gaps of undiscovered elements and predicted their properties. Then learned independently development a similar table to Mendeleev's, but is less known because he didn't predict new elements. Then Henry discovered the atomic number of protons in the nucleus, then recorded the periodic table by atomic number instead of the atomic weight, which is inconstancy. Then we have the modern periodic table that is what we know today. Elements are arranged by increasing atomic numbers. Then element is similar properties are in the same column or group. Rows, the periods correspond to the number of electron sheets, and that's it.
Hi everyone, my name is Alejandra, and today we're going to delve into the fascinating structure of modern periodic table. And this is the cornerstone of chemistry, and not only organizes all known elements, but also reveals the underlying principles governing their properties. By understanding the periodic table, we can better grasp the behavior of elements and predict how they interact in various chemical reactions. So let's get started. To appreciate the modern periodic table, we need to understand its history. The concept dates back to the early 19th century when scientists began to recognize patterns in the properties of elements, like Dmitri Mendeleev, and he was a Russian chemist, is often credited by creating the first widely accepted periodic table. Mendeleev arranged elements by increasing atomic mass and grouped them into similar chemical properties, leaving gaps for elements yet to be discovered. His periodic table laid in the foundation for the modern version that we use today. So, the modern periodic table structure is organized by atomic number, which is the number of protons in an element's nucleus. This arrangement resolves anomalies in Mendeleev's table, where elements did not fit perfectly according to atomic mass. The periodic table consists of rows, called periods, and columns called groups or families. The periods are horizontal rows in the periodic table, and there are 7 periods in the modern periodic table, each corresponding to the filling of a different electron shell in the atom. As we move from left to right across a period, the atomic number increases, and elements gain one or more proton and electron, resulting in a gradual change in properties. Now we have groups or families that are the vertical columns, and there are 18 groups in the periodic table. Elements in the same group have similar chemical properties because they have the same number of valence electrons, which are the electrons in the outermost shell involved in chemical bonding. In the first group, we have alkali metals. In the second, we have alkaline earth metals. In the third, we have transition metals. Fourth, halogens. And 5, noble gases. So finally, we have lanthanides and actinides. And these two are a series of elements that are placed below the main body of the periodic table, like in the last part. Lanthanodides include elements from lanthanum to luteolum, while actinodides include elements from actinium to lawrencium, and they are often called rare earth elements and include many elements that are important in advanced technologies and nuclear chemistry. So that's it for the structure of the modern periodic table.
Hi, my name is Regina Cruz, and today I'm gonna present you the classification of the periodic table. Okay, so now talking about this classification, it is divided in 3 groups that are metals, nonmetals, and metalloids. And now I'm gonna talk to you about what is about each one. Okay, some characteristics of these 3 groups. First of all, the metals is that are very good conductors of heat and electricity. They are found in solid state in a room temperature except for mercury. In appearance, you can say they are shiny and most of them gray, and basically their melting points and boiling points are higher. They are ductile. They do not tend to combine with each other chemically, but they can combine with non-metals. Okay, so now talking about non-metals are all the opposite to metals. Why? Because non-metals are opaque. They are very poor conductors of heat and electricity. Their melting point is very, very low, and they are not ductile. And they have 5, 6, 7, or 8 valence electrons. And non-metals can be found in the nature. So now we will talk about metalloids. Metalloids is in the middle. Neither is a metal nor non-metal. Basically, they are semiconductors, semi-ductile, and their boiling point is in the middle. It's not very high, neither very low, sorry. And basically, they look like metals but react as non-metals. Okay, so now I'm gonna tell you where they are, like where are located the metals, the non-metals, and the metalloids. Okay, so now basically they are divided, the metals, in alkaline metals, alkaline earth metals, lanthanides, actinides, and transition metals. And I'm gonna put somewhere here the periodic table, and we'll show you exactly where are found. For example, in alkaline metals is the first group, except for the hydrogen, of course, that hydrogen is a gas and it's not a metal, of course. That is the alkaline earth metals. Then there is a second group, alkaline earth metals, and then the lanthanides, anthanides, and transition metals. I'm gonna point you out here in the periodic table because they are mixed with other groups. Okay, so now about nonmetals. Nonmetals are into the right part of the periodic table. That is the 7th and the 8th family. That is noble gases and halogen gases. And also other that are not in those groups are carbon, nitrogen, oxygen, phosphorus, and sulfur. Now there are 7 metals in the periodic table. I know there are very few, but the 7 of them are boron, silicon, germanium, arsenic, selenium, antimonium, and tellurium. And basically that would be all about the classification of the periodic table, and I hope it had helped.
We're going to see the practice or the exercise from the evolution of the periodic table. First question, what is the law of octaves? The correct answer is that when we arrange by increasing atomic weight, it shows similar properties every 8 elements. Second question, Henry Moseley refined the periodic table by discovering that elements should be arranged by A. Atomic weight, B. Valence electrons, C. Atomic number, or D. Density. The correct answer is atomic number. Third question, it was the first work metal that was obtained from the mines. A. Copper, B. Silver, C. Oxygen, or D. Aluminium. Correct answer is copper. 4 questions. Elements in the same group of the periodic table have similar chemical properties because they have the same number of A. Protons, B. Neutrons, C. Valence electrons, or D. Electron shells. Correct answer, valence electrons. And the last question, what was Johann Doberhein's main contribution to the classification of elements? The correct answer is that he contributes with the triads. Or practice of the structure of modern periodic table. Question number 1. How many periods are there in the modern periodic table? A. 6, B. 7, A. C. 8, C. 9. Correct answer B. 7. Second question, how much groups are in the actual periodic table? A. 1 group, B. 2 groups, C. 18 groups, or D. 16 groups? Correct answer C. 18 groups. Third question, what is the trend for atomic radius as you move down a group in the periodic table? A. It increases, B. It decreases, C. It remains the same, D. It fluctuates. Correct answer 8. It increases. Fourth question, the main group elements are found in which blocks of the periodic table? A. S block and D block, B. S block and P block, C. D block and F block, or D. P block and F block? The correct answer is B. S block and P block. And the final question is, how does electronegativity change across a period from left to right? A. It decreases, B. It increases, C. It remains constant, or D. It fluctuates? The correct answer is B. It increases.
Now, to continue with the practice, I'm going to give you some exercises for you to complete. Number 1. Identify the group and period of the following elements: sodium, chlorine, calcium, and argon. The answers are sodium group number 1, period number 3, chlorine group number 17, period number 3, calcium group number 2, period number 4, argon group number 18, and period 3. Number 2. Classify the following elements as metals, nonmetals, or metalloids. Number 1, silicon. Number 2, bromine. Number 3, magnesium, and sulfur. The answers are silicon metalloid, bromine nonmetal, magnesium metal, and sulfur nonmetal. Number 3. Determine whether the following elements are alkaline metals, alkaline earth metals, transition metals, halogens, or noble gases. First, lithium. Second, iron. Third, iodine. And fourth, neon. The answers are lithium alkaline metal, iron transition metal, iodine halogen, and neon is a noble gas. Number 4. It says, describe the physical state, solid, liquid, or gas, at room temperature for the following elements. Number 1 is mercury, number 2 is nitrogen, and third is iron. The answers are mercury, liquid at room temperature, nitrogen, gas at room temperature, and iron, solid at room temperature. Number 5. It says, arrange the following elements in order of increasing electronegativity. A. Boron, carbon, nitrogen. B. Fluorine, chlorine, and bromine. C. Sodium, magnesium, and aluminum. The answers are A. Boron, carbon, nitrogen. B. Bromine, chlorine, fluorine. And C. Sodium, magnesium, and aluminum.